This is Don Larson. We are ready to get started. So for those of you who are not familiar with Larson Software Technology, we're based in Houston, Texas, and we were founded in 1984 as graphics technology experts, and have been doing that for over 30 years. We develop powerful, innovative 2D and 3D graphic software and toolkits based on open standards. We've always, from the very beginning, promoted the CGM standard by providing a free CGM viewer, which has now been replaced by a subscription version, which you can buy online on our store. We're known as the developer of the first HTML5 CGM viewer that eliminated the need for plugins for browsers. We're a member of the CGM Open Foundation. Larson Technology products simplify the graphic workflow for illustrators and technical publication professionals. Our agenda today will be, we'll start off with an introduction to 3D illustrations and kind of set the context for this presentation, and then we'll go into the basic essentials of 3D graphics exchange and formats. And then we'll talk more about the process of creation and display of 3D graphics. And then we'll have an actual demo of creating an animation and then actually viewing it. And then we'll summarize, and then we'll wrap up with a Q&A where we'll address your questions. So let's get started. I'm going to turn it over now to David Manick, who will give the main part of our presentation.
Thank you, Don. Good morning, everybody, or good afternoon, or good evening. Thanks for joining us. This is our first webinar for some time. So apologies for people who've attended in the past and have been looking forward to the next one. Things that changed this year, mainly for us, was we had our first kind of in-person events. We had a couple of in-person events in the USA, which was great. Good to meet people again and obviously talk to them in person. So we decided to do this webinar. It's very specific to one area of illustration, and probably a very new one to most people as well. The reason we did it or decided to do it was that when we've been demonstrating our VizEx Edit 3D software earlier this year and before, one of the questions that always came up was, do we support animation or 3D animation? So we decided to do this very specific webinar on that topic. So again, thanks for joining us today. The session is being recorded, so if you need to step out, don't worry, we will post the recording post-webinar, probably tomorrow. So probably many of you probably know that Larson, we've been very kind of traditional in our support of 2D graphics, in particular the CGM and SVG formats, and have been for many years. But many of our customers began to ask us about our 3D strategy, what we were doing in that space. And it was very specific at the beginning that they wanted to really convert 3D data to 2D data into CGM and SVG to create kind of a traditional type illustration. So we completed that in the first version of VizEx Edit 3D, which obviously is available today. But when we were viewing the model and we were moving it around in 3D space, we also had the questions around, well, how would we deliver the 3D illustrations as opposed to converting them to 2D? So that was really the next task that we put in front of ourselves, is that how would we support authoring 3D data, but also displaying it? So there are many 3D file formats out there, too many to name and describe, but that was really important to us that we selected the right one for display. And we also had to look at what technology was needed to actually deliver these illustrations. So we really see there's four components required to deliver effectively 3D illustrations successfully. And that is really, one is that we need a capable 3D file format for delivery and display. We need to develop something easy to use to author that 3D data. In other words, an easy way of animating and manipulating the 3D model. Also, at the other end, we needed a way of then displaying that data in a web browser environment. In other words, a 3D viewer that didn't need a standalone application or a plug-in technology. And at the same time, this would need to be eventually that 3D viewer embedded into some IETM, IETP solution for viewing for really for the end user to see or manipulate that data and use that data effectively. So hopefully today in the webinar, we'll talk about that, but we'll also demonstrate how that can be achieved. So the first part really is 3D data exchange. Where is this data, this 3D data originated and being held? And it's really going to be in your CAD systems. So if you're within, most companies now are using CAD systems either to model their equipment and then obviously use that to manufacture the equipment, but also in the realms of using it for technical documentation, technical data as well. So the kind of the top ones you'll probably have heard of are like CATIA and Creo and SolidWorks, Inventor. So the main commonality with these is that they support open formats, so we can get to that data and reuse it. So if we want to repurpose that data and convert it to 2D or reuse the 3D, we're going to need to import it into our authoring software or illustration software. So the main two that we're supporting at the moment, this is notwithstanding we might support other formats in the future, is we're supporting the open standards of STEP and IGES. And both of these are supported within probably 100% of all CAD systems, so it'd be very rare not to support them. And especially STEP. So the majority of our customers at the moment are using the STEP file format to import that data into VizEx Edit 3D. So these are, I think it's important that they're open. We could potentially support native formats, but that would be something we would look at on a case-by-case basis. So, but at the moment, most people are able to access STEP or IGES, and then we would easily import that into our solution. Um, 3D display format. So before we made a selection, we looked at quite a few different ones. And there's a lot of criteria that we wanted to make sure that we tick the boxes for before we made a selection. So we looked at things like X3D, which is an XML-based 3D format. We looked at VRML, which has been around for many years. And we also looked at 3D PDF. And the other format we looked at was GLTF. So there was reasons that we didn't select the top three. X3D really was because although XML sounds really a good standard to follow, the file sizes were kind of prohibitive. So that was one of the reasons we abandoned that. VRML was a good candidate, but we felt that we wanted something that was more kind of the moment, and certainly and 3D PDF again kind of caused problems if we wanted to integrate it with say into an IETM. So we selected GLTF as our preferred format. Again, that doesn't mean preclude that we'll not support other formats in the future, but GLTF ticked all the boxes. So if we're looking at the four components, this was obviously number one, selecting the right format. So GLTF, it's an open standard. It's run by or managed by the Kronos organization. There's the link at the top there if you're interested. It's available in two kind of flavors, GLTF and GLB. GLB is a binary file which contains all the attributes of the 3D data. This is the one we kind of favor as the best way of actually exporting the data out of our solution. It doesn't require a plugin for the web browser, which was key, so there's no plugin required. It's very efficient in loading the 3D data. It optimizes the size of the file, so we can have quite small file sizes. And also it has very good support by Microsoft and Adobe, so it's kind of industry well received as well. Microsoft actually have a viewer that comes with Windows that supports GLTF and GLB, so that was a factor. And finally, this only happened this year, is that it became an ISO standard, which is really key for if we want to go into specifications like S1000D, where they like to have file formats that are open but also industry standard. So again, there's a link there. You'll get the slides, so you can click on these links to follow it. So it is part of the ISO standard. So how do we create the graphic and display it? That's the key here. And what software do we use to do that? So you do really need a piece of software that has the ability to effectively reuse that data. And there are a lot to choose from, which we'll move on to in a second. Needs to support step and IGES, obviously. The ability to easily repurpose the 3D data, I think that's key. And into a technical illustration. Also, it should have animation features. So if you want to create a kind of a procedural type illustration, then that will be important. The ability to animate the components moving in different directions. And as I said at the beginning, there's just a plethora of 3D software available, ranging from free to pretty expensive, that will do some of these tasks for you. But they tend to do a lot of other things as well and can be quite overwhelming and complex. So our task really was to create something really easy for the end user or the illustrator to use. The next element is, now we've created this data, we need a way of delivering it. So although the GLTF and GLB doesn't need a plugin, it certainly needs some kind of help creating toolbars and things like that. So we created a 3D viewer that would then work with these files that we're actually authoring. And the key behind this was that, and one of the reasons we selected GLTF was that a lot of the illustration requirements were part of GLTF, so it can be interactive. It could link to XML data. It had an ability to annotate, add annotations to the 3D file. It was a really small file size. And finally, as I said, it's easily integrated within a web browser or an IETM, Interactive Electronic Technical Manual, without a plugin. So it kind of ticked all the boxes that we were looking for. So today, there's not many slides, you'll be pleased to hear. It's mainly, I'm going to do some demonstrations of the technology, so you understand how you would use it. So let's open up VizEx Edit 3D. So this is our 3D software. We can import, as I said, we can import IGES and STEP. So we just import that information into here. We do support other formats as well, but those are the main ones that are being used today to import into the software. So STEP and IGES. So this is a STEP model. It's quite a large model of an engine. And we get the model tree on the left here. and we can start working with this. We click on, say, the fan at the top here, and it will identify it over here in the model tree. So this really gives us the ability now to start working with this. We can move it around, and we can say, I want to select a particular part. We see that's part of an assembly, and then we could isolate that out and start working with that in isolation. And then we have the options to move this, to move it and view it in different views, like the isometric. So we can look at it in different views and then start working with the different parts. So we might want to explode this part off and begin to make a kind of an illustrated parts catalog information. And then we could export out as CGM or CGM, and then have a 2D illustration. So I said that was our first real big functionality within VizEx Edit 3D, taking that information and then taking it to CGM as a 2D file, and then adding annotations and so forth to it. So all I would do then is export, and I have the CGM option here to go to a CGM file. So I did mention SVG. One of our plans is probably to put an SVG option in here, but once you've got the CGM, you can also convert to SVG as well. Okay, so I'm going to now import we can also import GLB and GLTF as well, so we could, in theory, round trip them. So I'm going to open a GLB file. So this again is a very small engine, but this time we're gonna look at the animation and what we're able to do. So this is a new function. It is in the newly released version. We are going to add some more functionality to it. So anybody who's have the software already, this will be just available as a tab at the top here, and then we can begin to work with this. So the first part would be creating the animation itself. So I just want to give it a name and click OK. And as soon as I do that, the timeline down here at the bottom appears. So it now recognizes what I want to do with this file. So if I want to say explode this particular part off the front, you can see I get these directional arrows, and I also get the dialog here, transform component. So the first option is to move this. So if I move over the directional arrows, I can drag this away, and it records that for me, and it adds it to the timeline. And we just give it a default time to begin with. If I then apply this, then that is recorded. So if I just want to play that back, we have the playhead here. I can just hit the play, and it will explode that particular part off. So it's really that easy. If I want to extend the time it takes, then I can just drag out our keyframe here. So now it will do the same thing, but it will just take longer to get there. So hopefully you begin to see how easy it is just to begin creating animations in the software. So if I now click the part at the back, again, automatically adds to our timeline. This time I'm going to move it in this direction. And again, it's recorded it. It just gives a default time to begin with, and then I can apply. So I've now added my second part moving. And what I could do is just now test that and play that back. Okay, at this point, I just want to go over to the viewer because I'm going to save this. And then if I might just, no, I don't think I'll close it. I'll just leave it as it is. So let me just look at the thing here. So now I'm going to go to the viewer. And I should be able to open this up. So this is VizEx View 3D. It's an SDK, a software development kit. which anybody can evaluate. But this is just a default window we've created in Chrome. And a lot of the controls that are available, you'll see here for the viewer. But this is not probably how you would use it, but it just gives us a test area. So we could just go to this particular file. In fact, it's, I'll go to this one, I think. So now we have this file in here. We have the ability to play that animation back. So the front part or cover removes, and then the back part removes. And at this point, what I did is actually add a camera in, which we'll look at in a minute. So we can also change the orientation of this as well. As I said, this is just a standalone in a Chrome viewer, but we usually probably see this within an IETM alongside text and so forth. So just continuing this, if I click on this cover here and move this away and apply, now I've added another component to our timeline here as well. And I'm now going to click on this gear wheel. And instead of moving it, I'm going to choose one of our other options, which is to rotate it. So if I now say rotate, I can choose the axis I want to rotate about. And then I can put in, say, 360 and apply. So hopefully now what will happen is that this will rotate at that particular point. So if I play back, now it should remove the cover and rotate the gear wheel. And we could also, in theory, do the back one as well. So we'll click and add that one. And we'll say rotate again. We'll say 360 and apply. And if we want them rotating at the same time, I should be able to just drag this back, and then they should rotate. Oh, I didn't choose the right axis, did I? Let me just add that one in again. Yeah, I didn't. So my mistake there was I didn't rotate around the z-axis. And apply. Let's just drag that back. And let's just run that through. You should see them both rotating. I'll just zoom in a bit so you can see that a bit better. Okay, so what I could do now is actually add a camera view. So at this point, I might want to actually zoom in on this as it's happening. So if I go to transform, and this is a really new feature that we just added in, is camera, is that now if I zoom in at this point, that is captured. And again, I should be able to move this back to here. So when it starts rotating, the camera zooms in. So let's just play that back. And obviously we can move these around to suit, and then we would export as a GLB file and then open in our viewer. So what I think we've achieved something that's really easy to use. You can see I've only been working on this a few minutes, and it's already usable within our viewer. Okay, the next thing we'll look at is I'm going to, let's just save this. And I'm going to probably try and export this. So let's just call this 3. Okay, I'm going to save it into our folder here. Export animation. So this is a GLB file. Okay, and I'm going to go back to our viewer. Let me just do the page, and I'm going to go to our upload. Let's see if I can find it. This is where I always struggle to find the files I've just done. So this one here. I didn't save it in the state. So sorry about that. Okay, so this is not going to play very well. So what are the mistakes I made? So we made it really easy, obviously. So let me just go back. And I saved it in this state where I should have saved it at the beginning. So let me save that and export again. And we'll say it's the animation. Okay. This is a live demo, as you can see. So let me just refresh the screen, and we'll do the same thing again. So apologies. This time, let's play that animation. And I'll talk to our developer on the viewer. They should obviously have not done that. So, but rotated, these should rotate as we saw on the authoring tool. So we're still working a bit more on the viewer side, the SDK for the viewer. So if Mark is watching, he can have a look at that. Okay, so the other things we're looking at here was like illustrated parts data. Although there's no real animation involved here, what I wanted to show you here is this is the 3D viewer again, but here we can have an interaction between the text and the model. So if I click on the table here, it will highlight the part on the left-hand side. So similar to 2D, we could also have a similar thing that we in 3D. So, and this is another reason we chose this format, was it gave us that similar feel that we get with the 2D graphics, interactions between tables and the graphic itself. So this is all done in HTML. So if I go to sheet 1 here, this isn't animating, this is just putting a new graphic in. Although it looks like it might be animating, but the key is here, it's updating the table. So we see the table is updated to reflect the illustration we're looking at. But in theory, you could have it could be animation on this side as well. And that's where we get to our next thing here, is where we have steps. So you could see that I removed, when I authored it, I removed the cover and then the back cover. So they might be steps in a procedure. So here I just have a paper punch, for instance, and I have steps in the HTML here that I can click on and remove these parts. So step 3, step 4, and step 5. So now I've got an interaction between the text and the graphic that enables me to step through something. So I can, let's just go back to the beginning. So if I go to step 2, you could have something that calls you out to say you haven't done step 1 yet. So you really need to do step 1 before you go to step 2. So some kind of warning system that goes to the end user to say, please do step 1 first, and then you will allow you to go to step 2. So this is, again, something you would see in a maintenance manual, or disassembly, assembly, a different step. But obviously we're doing this in now 3D as opposed to 2D, which can give you an advantage in there, as we showed with the camera, that we could reorientate the view to see what's on the other side rather than just see this flat view. And we move this out. So even though I might move this to a different direction, the next step will still initiate, so I can see a better view of the all-round model. The final part really is to the fourth component was the IETM itself. So how do we integrate with that? Well, the integration really comes with the viewer. So Raytheon, one of our customers, kindly gave me this demo that they've created. So they have an IETM mainly aimed at the S1000D market, but it obviously could be used for other markets as well, where they have an IETM called Eagle Vision, where they've integrated our 3D technology. So this is just one single piece of information. Obviously, on the left-hand side, there could be lots more information on other parts of this particular equipment. So we have a disassembly procedure, and if we scroll down, we see this is obviously a data module XML, but now we have steps. So we click on step 1, and it does the same thing with the paper punch. So, but now we have not just a HTML, we have an XML IETM doing these particular steps. So it's kind of come full circle. We've got the author inside where we've authored the information up through and using that format GLTF, and then we have the viewer, which is over here, and now it's not just standing in a HTML, it's now part of an overall solution to deliver information to the end user. So I thought that was important that we showed the whole thing fitting together, that we can import the data from STEP, we can then author the data within VizEx Edit 3D, we can export in a format for the viewer, and then the viewer is then integrated within an overall solution for the end user. Okay, let's just go back to the slides. So thank you again for Raytheon, the Raytheon team, for providing that for us today. So VizEx Edit 3D, you saw a demonstration. You can easily import those 3D models and repurpose them as technical illustrations. You can recreate views and orientate them. The 3D model is required to get the most out of the information that you've got from the engineering department. We can explode those components out from the assembly to create illustrated parts illustrations. We can convert them the 3D to 2D as CGM and SVG. But as we've been looking at today, we can also now create 3D illustrations and include animation, export them to GLTF and GLB to use within our web environment. VizEx View 3D is the viewing part of the solution. It's not for everybody. It's a way of where vendors or software vendors or suppliers can integrate this technology into their solutions. So it's a software development kit. It's easy integrated. It will display those interactive 3D illustrations. It will embed within a database. So it could be a CSDB, for instance, for S1000D. So you can manage and preview that 3D data within the management part of the scenario. But also, more importantly, it allows us to then display that information within an electronic manual with all that interactivity. So we could have the procedures which support in animation. We can step through those procedures in a 3D way. And also we can link that to the XML data for procedural and also the spare part catalog information as well. So just to summarize, we think we've made some significant progress over the past year with 3D. We really want to make a stance on supporting open formats, and that's why we chose GLTF, also an ISO standard. And we'll always be looking at the standards and try and make those compliant to the different specifications that are out there. This does not mean we're going to neglect 2D. We have a strategy for 3D, but also we have equally a strategy for 2D because there's a lot of legacy that will need to be maintained for a long time. It might never go to 3D, so it has to be maintained, and we have to maintain our tool VizEx Edit, just the standard version, to support those graphics and continue to work with them. So this is not going to, we're not going to neglect that area. We just wanted to make sure that we give our customers an option for 3D if they needed it. And obviously we're really pleased to work with any companies out there, organizations, be them end users or vendors that want to integrate our technology in the future. So if you have any questions, please post them. I should have said that at the beginning, to be honest. Please post them now and we'll be pleased to answer them. I apologize for some slight glitches on the viewing side, but I think basically I think we've covered everything today we wanted to. One question here is around the free software and CAD software. Why wouldn't I want to use those? I think like with anything, with any software out there, it's much easier to use that something's been designed specifically for that task. And I can kind of answer that firsthand in the respect of I tried to use Blender to do animation of GLTF, and it's a fantastic tool, a fantastic 3D tool, but just to do animations, it's very, very complex, and it can be overwhelming to try and do it. A lot to learn before you even get to try and start an animation. So we just wanted to make that task as easy as possible. Also, why did we select GLTF and GLB? I think I did outline the major points before. Don, from a technical point of view, what have you found working with GLTF and GLB? Have you got any comments on that?
Well, it's extremely efficient, both in file size and in the time it takes to render them. What I was really impressed with is when you put it on an iPad or Android, it works just as fast as it does on the native desktop, like on a Windows or Linux machine. So it's very impressive and it's extendable. We've had to use a couple of extensions ourselves to get to compression and stuff like that, but the format itself is really impressive, and the support from the organization, that's the Kronos organization, which is a consortium of very large corporations, Apple and Microsoft and Adobe. They've been very supportive. So it's been a really pleasant experience. So.
Yeah, I think so. It just really is a format that we've been really impressed with. I think for the S1000D people out there, it is it's not part of the specification. It doesn't kind of say you have to use this format. So if you look at the spec, there are some 3D guidelines out there, but most of them are very general and high level. So the danger is that a lot of people might just use any file format they come across, or native file formats, which is probably not the way to go. Certainly choose something that's open. That would be our recommendation. Don't choose anything proprietary for delivery of 3D data as part of any specification. So we do have another question about animation timeline, about the steps. One thing I didn't go into, if I go back to the illustration here, we probably say we wouldn't create this as one timeline, that we might create steps as individual animations, and then we can reference those back into the XML. So you can have if we go back to animation here and manage, let me just, I don't think I saved that. I'll save and close it and manage. That we can have a separate animations. We could have step 1, step 2, step 3, and we can reorder those and then play them back. And then that will be a lot easier to reference within the data module. So we could reference each step and play that back individually. So I'm just reading another question here. Okay, so when bringing in parts from different software such as CATIA, will the assembly retain its original orientation view or default to isometric? That's a good question, and that is one that you really don't know until you've imported the file. It's what we say is that once you've got it in, you can then reorientate it as you wish to the view that you want. So there doesn't seem to be any kind of hard or fast rule on how the view is set up in the step file. So when it's saved when it's exported a step from the CAD system, we don't really know what view it's going to be. But when we get it through, we can then reorientate it to the view that we want. Will he be able to delete copy objects in the animation? That's a good question, Don. Do you know? So we can delete copy in the normal model view. I don't know if you can delete here. Let's just have a look. So am I animation? Yeah. Let's say edit. Okay, that I don't know, so I'm going to do it on the fly. The answer looks like yes. I deleted that. But copy is an initial. It's something we might have to look at because I don't see copy in here. So just being able to delete doesn't seem to be the right way.
Well, it's there, David. You just have to select it, and then it'll become highlighted.
You're right. Sorry. Yeah, and so copy.
Now copy.
Good point. Base. Yeah. So it did create. Yeah. And it did seem to. Yeah. It certainly adds. Can you see it adds it to the model tree down here as a copy? So in theory, then we would have that as accessible to animate. Good question. Thank you. Will we introduce a fizzle out option for parts? Yes. So when we fizzle, or we could also call it fade. So as you pull a part away, that we'll have an option to so when we pull it away here, when it's got to the place it's going to, that we then have the option in the timeline to fade it, so it kind of disappears. So that could be good in the situations where you have a very cluttered illustration and you need to create more space. So the other way I look at it is if you're removing this part as the engineer and you're taking it away, you then put it on a bench or something. So it would, in theory, be not disappearing, but it'd be somewhere else. So that's kind of in real life kind of thing, a scenario. So short answer is yes, we will introduce a fade function. It's not in the current release version, but it's something we've done, I think, but it's not in the release version.
Yes, it's in the authoring already. The not the release version, but the beta, and then we're implementing it in the viewer. So yes, indeed, that will be part of the product shortly.
Yeah, the other thing that I think this question is about, can we rotate on a different axis? So at the moment, we only really rotate around kind of the center of a component, but in the future, we're looking at rotating about a specific edge. So in other words, a good scenario would be like a door on a cabinet. So you could say, I want to rotate about the hinge point. So you could show the door opening or closing. So I think that's the best analogy of that. So we are looking at that. We don't have that we haven't done that particular function yet, but we are looking at and working on it. It's quite difficult to do. But we are working on it. Can you customize the animation speed? You can adjust the speed by if this particular bar here is the time it takes. So if I drag out, I'm increasing the amount of time it takes to get to that point. If that's what you mean, I suppose you could say, can you adjust the speed of the overall animation once it's in the viewer? That I don't believe you can do, Don. Do you know that it'll just play back at the speed that it's been authored in? Do you think
Yes, that's
can adjust the
correct.
speed in the viewer at all? That's an interesting. If that is the question, that's an interesting one.
Yeah, that's a good thought.
Yeah.
But
It's certainly
yeah,
not an
currently,
option we offer at the moment. If that was the question, once we've created this, do we are we able to kind of adjust the speed in the viewer? So I suppose the answer is no at the moment, but I think sometime in the future we'll probably look at that. So anyway, so you can see that we can adjust the amount of time it takes from here, and also the fact that it was rotating in the thing here. Okay. So thank you for the questions. Quite a lot of questions there. That's very good of you. Thank you. Let's just go back to the slides. So just want to thank everybody for attending today. We're still obviously working on certain areas of the technology and working with other partners on integrating the technology, but we believe we've got a really good solution for the illustrator, to create these animations, that they can create them really quickly and easily, and also then introduce them into their overall documentation for their equipment. And so far, we've had some really good feedback from users and evaluators of the software. So, and we're responding to those. We're trying to add new functions in all the time, and obviously, as I said earlier, we're not neglecting our 2D area either. So we're working on both VizEx edits in tandem. So with that, I'd like to thank you for attending. We will be sending out post-event links to the recording and also to the slides. So I hope everybody has a great rest of their day, and we'll speak to you on the next webinar. Thank you for joining us today.